Okay, class to Alpha, how do you do? Can you hear me? Good morning. Can you hear me, class?
Can.
Okay, thank you, Wei Xiang. Okay, so my presentation, make sure you also can see my presentation, yeah? Right. Okay. Is it okay? Everybody's ready?
Yes.
Okay, good, very good. Right. So yesterday I asked you to do the workbook exercises from page 65, 66, 67, and 69. Do you have any problem about the exercises before we continue today? Or you want to discuss it?
Discuss.
Discuss, okay, like this. You just give me the page number and then the question number, okay, and then we discuss discuss the exercise, the question together, okay. Okay, I go one by one, right? So I will open the question first. I will try to open the workbook, the digital version. Where is it? Okay, this one. First command, chapter 6. All right. Okay, 230. Okay, we start from page 65. Yeah, page 65. Yeah. So I think this is the properties of acids and alkalis. Okay, the aim for today, the page 65 is to study the properties of acids and alkali. Right. We have a few activity here. Okay, and then observation, and then the properties. Okay, the first activity or the first characteristic is by the taste, right? And then you must remember, all right, usually acid tastes sour. Okay, usually acid will taste sour. Okay, and then for alkali, usually it will taste bitter. Okay, so this is the first properties of acid and alkali by their taste. Okay, we can differentiate or we can compare the what we call the characteristic of acid and alkali by their taste. Okay, so acid tastes sour, of course, and then for alkali it will taste bitter. Okay, okay, A is okay, no problem. How about B? Okay, B is the activity to test their corrosive properties. Corrosive properties mean what? Okay, when you touch the acid, it will corrode the material. Okay, for example, if you accidentally touch the acid or alkali, it will hurt your skin. Okay, if you try to drop one drop of acid and alkali into the filter paper over here, for example, here, if you look at the picture, you try to drop one drop of acid and alkali onto the filter paper, and then maybe about a few seconds, the paper will make a hole over here. It will corrode, right? And then it will what we call a burn a bit. This is if you are using strong acid or alkali, or we can call it concentrated acid or concentrated alkali. Okay, it will make a hole on the paper, and then we can conclude that the second properties of acid and alkali is it concentrated acid and alkali are corrosive. Okay, B. Is it okay? And then C, litmus paper. This is the third characteristic. what happened to the acid and alkali when we touch it with the litmus paper? You must remember the color changes. Okay, I think it is easy for you to remember. If the substance is acidic, then it will the color is red. When the substance is alkali, the color will be blue. Okay, that's all. Right? C is no problem lah. I think C. Are you with me, class? Are you with me?
Yes.
Okay, make sure you are following me. And others, I hope others also good. You try to follow me, right? Okay. Characteristic C, no problem. You just remember when it is acidic, it will turn red. The litmus paper will turn red. And then when it's alkali, it will turn blue. That's all. Okay. Next page, page 65. The next properties, you can turn to page 65. The next properties is D. D. Okay, D. pH value. You must remember the pH value. If you still remember the pH value over here, for example, I will open the image for you. This is the pH value or the pH scale. Okay, pH value or pH scale. We can test whether the substance is acidic or alkali, or we can also test the strength or the scale or the value of acid or alkali by using pH paper. Okay, by using pH paper. All right, this one, pH paper. pH paper not only it will determine whether it is acidic or alkali, but also it will try to determine the strength or the value of the pH, whether it is acid or alkali. This chart over here, you must remember. Okay, how about the color? I think the color is just for your reference. The color is just for the reference. You no need to remember the color. For example, number 0 is red, number 1 is orange. No need to understand. But the most important thing you must remember is which scale is acidic and then which scale is alkali. And then at the middle, number 6 is what, class? Number 6 or number 7? Number 6 or number 7 is neutral. Okay, number 6 or 7 is neutral. I think it is number
7.
Number 7, yes, number 7 is neutral. 7 is neutral. What's meaning by neutral? Neutral, it means it is not acidic, it is not alkali. It's in the middle. Yes, it is not neutral, it's not acid, it's not alkali, it's in the middle. And then it's more than 7, it is acidic. And then if, less than 7 is acidic. And then is it more than 7 is alkali. Okay, less than 7 is acidic. And then which one is stronger? For example, if I take the scale of acid between 0 and 6, which one is much stronger acid? Number 0 or number 6? Number 0 is, yes, very good. You just remember that. No need to remember the color. All right, the color is just for your reference. Why there is a color over here? Because when you put pH paper, okay, for example, if I try to see the what we call if you try to put the pH paper, pH paper, okay. If you try to dip, for example, this picture over here, okay, if you try to dip or touch the filter paper on into a substance, it will change the color. And then you can try to cross-check the color that is changing in the changes in the pH paper by its reference, the nearest color. This way you can estimate the value of the pH, whether it is acidic, whether it is alkali, whether it is strong acid, or whether it is a light acid. Okay, by using the color code over here. Okay. The sample. For example, okay, this one. For example, this one. The other picture over here. You see? You must use it. Okay. You must use pH paper together with the scale. All right. If you look at the picture over here, picture on the picture here, this one. Oh, you very big. Yeah. Okay. This is pH paper, right? This is pH paper. This is pH paper that already dipped in the substance. And then you can see the color changes here. What's the color here? The color is about green. And then you must match the color that are produced in the pH paper by the scale here. This is what we call the scale or the chart. The pH scale or the chart. And then you can estimate, oh, this is about, what is the, what is the value of the substance here? It is acid or alkali? Can you see the picture? I try to zoom it a bit. I try to zoom it a bit. Okay. Can you see it? Can you see the value? Can you see the value? Okay. Can you see the value?
10.
Okay. So the pH paper over here change color when you dip into the substance, and then it will turn green. In this case, it will turn green, right? So what are the nearest color according to the chart here? The nearest color is it 7? Is it 9? Or is it 10? Or is it 11? 11, no lah. Yeah? It's about what? It's
9.
about 9. 9 or 10? Which one is nearest? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe about 9 or 10. Right. Maybe about 9 or 10 pH. Okay. 9 or 10, it is acidic or alkali according to the chart here. According to the chart, pH 10 is acid or alkali?
Alkaline.
Okay,
Alkali.
it is. Yes, very good. It is alkali. And then what is the value? The value is 10. Okay. The value of 10, is it the strong acid or the weak acid? Sorry. Strong alkali or weak alkali? 10. pH 10. How do you think?
Weak.
Weak or strong alkali, you think? pH 10.
Either.
This in the middle, right? For about middle. pH, this one, pH 10. pH 10. pH 10. Okay. Alkali is, what is the range of alkali pH? pH 8 until pH
14.
14. Okay. This is for alkali. This is for alkali. So pH 10 is about 8, 9, 10, 11, 12, 13. It is about in here. pH 10 is about in the middle here. So you can say that it is not weak acid. It is also not very strong acid. It just sit in the middle right there, right? So you can differentiate. So the pH paper want to indicate you whether the alkali or the acid. In this case, alkali. In this case, in this picture, they test for alkali. Okay, pH 10. Okay, pH 10, of course, is it alkali, but not so strong alkali because the pH is only 10. Okay, if the paper turn purple like this, or it pH 14. pH 14 is a strong alkali. Okay, can you understand this? You must understand this, then is it okay? Right? Can I continue?
Can.
All right. So, acid hydrochloric, you just write over here lah, yeah, is about pH 1 to 2. And then for natrium hydroxide, so sodium hydroxide, pH 13 to 14. And then what is the conclusion of the properties of the acid and alkali? If you are using the pH value, acid less than 7. This one, acid less than 7, and then alkali more than 7. Okay. Right. Next one. E. Okay. When you put metal such as magnesium, such as iron, such as copper, such as what? All the metal you put inside the acid, what will happen? There is a reaction. I will try to find the video first. Metal and acid reaction. Okay. Okay, maybe there is a video here. I will try to show you the video first. And then we got the video. Oh no. Why so slow? Oh no. What happened here? Very slow lah. What happened? Oh, what happened to the internet? It's very slow lah. Oh no. Okay, never mind. I don't know what happened to my internet. Right. Okay, like this. Okay. When you put metal inside the acid, it will produce a gas, and then the gas, when you try to test it with a wooden splinter, lighted wooden splinter, it will produce a pop sound. Okay, there is a little explosion, meaning that the gas created is hydrogen, and then when you put metal inside the alkali, no changes. Okay, that's all. Right, for the reaction in metal. When you put metal into the acid, there is a reaction. When you put metal into the alkali, there is no reaction. Okay, there is no reaction, meaning that there is no gas released from the metal. But if you put metal inside the acid, there is a gas released from the metal. The gas is hydrogen, right? Okay. Next one. Number 1. Based on the given general equation, complete the word equation below: metal, acid, salt, and hydrogen. Okay. This is a few metal when react in different type of acid. Okay. You can take the answer over here now. Okay, this is page 67, right? Page 67. Okay, actually there are many type of acid, and then the most common acid you must know is number 1, hydrochloric acid. Okay, hydrochloric acid, and then sulfuric acid, and then nitric acid. There are many types of acid, yeah, but I think in form 2 you just remember these 3 types. Okay, hydrochloric, sulfuric, and then nitric acid. Okay, and then on the left here is the metal. Number 1 is zinc, magnesium, and ferrum. Ferrum is what, class? Ferrum is the chemical name for what? Ferrum. Anybody? Hello. What is the official, not official? What is the chemical name for? What is the
Iron.
common name for ferrum? Yes. Sorry.
Iron.
Iron. Yes, very good. Ferrum is iron. Yeah. Iron is the common name, and then the chemical name we call it ferrum. Okay. All right. So this is zinc, and then this is magnesium. You must remember, yeah, any metal when you put inside acid, it will form a reaction. Is it true? If you put metal inside acid, it will react. It will produce what gas? It will produce what gas? Plus
Hydrogen.
hydrogen. If you can see here, A also hydrogen, B hydrogen, and C also hydrogen. But it will form, according to the equation here, when you put metal into acid, there will be a reaction that will produce hydrogen and salt. Okay, so what is the salt change when there is a reaction? For example, hydrochloric acid will form zinc chloride. Magnesium will turn into magnesium sulfate for sulfuric acid, and then for ferrum it will change into ferrum nitrate. Can you understand this? Boleh faham tak ini?
Can.
Can, eh? So just remember like this, very simple one. Chloric here, chloric will become chloric over here. Wait, chloric. Okay, chloric, hydrochloric. Chloric here will become chloride, and then the metal here will become zinc here. Chloric will become chloride. Okay, and then sulfuric here will become sulfate. Sulfuric will become sulfate. Nitric here will become nitrate. Okay, now what we call nitrate here will become nitrate. So if I have another question, okay, we just wait for a moment. If I have another question, for example, I have copper. Aluminium lah. Aluminium plus. Okay, aluminium is a metal, right? Aluminium plus nitric acid. It will become what? It will become what? Of course, what is the gas produced? Hello?
Hydrogen.
Nitrogen. Aluminium plus nitric acid will become what? Anybody? Based on the above example, same.
Ferrum.
If I use aluminium is a metal. When I put into nitric acid, it will become what?
Aluminium nitrate.
It will become aluminium nitrate plus what? What is the gas?
Hydrogen.
Yes, hydrogen. Another example. If I use copper and then I put high sulfuric acid, it will become what? Become what class?
Copper sulfur.
Copper what? Sulfate, copper sulfate plus what?
Hydrogen.
Hydrogen. Okay. Any reaction, when you put metal inside any acid, the gas produced is hydrogen. Okay. But the salt produced based on the metal put. When you put aluminium, it will become aluminium. For example, if you put aluminium inside hydrochloric acid, it will become aluminium chloride. Okay. You remember this one. Okay. Chloric will become chloride. Sulfuric will become sulfate, and then nitric will become nitrate. And then at the front here is the metal. Okay, you understand this? Boleh, huh? Okay, I hope you can understand it. Huh? Right. Okay. Right. Okay, so number 2, question number 2, page 67. Okay, pineapple and star fruit have sour taste. Okay, sour taste, sour mean it is acidic or alkali. Sour mean it is acidic. Yeah. Okay. Number 3, take the substance that has alkaline properties. Yeah. Kiwi fruit and tomato is usually acidic, all right, because the taste is sour. But soap, have everybody taste the soap? You pernah rasa sabun ya? Sabun, it is not sour. Usually it is bitter. All right. And then one of the example of the property of alkali is it is slippery. Okay. When the thing slippery, licin, and then it tastes bitter. Usually it is a properties of alkali. Okay. Number 3, is it okay? Okay, I go to number 4. Right. So if you look at the picture here, you try to determine whether the dry soap powder here acidic or alkaline. Okay, I just zoom it a bit. Okay, dry soap powder, and then you try to use litmus paper and then try to test it whether it is alkali or acid. Success or not success? Can you just touch the litmus paper, use the litmus paper just to touch the dry soap powder? Can or cannot?
Cannot.
Okay, it is cannot. Yes, you cannot test the dry soap powder because why? You must put what? You must put?
Water.
Yes, you must put water. Remember class, in order to test whether the substance is acid or alkali, you must put water. There must be a presence of water. If there is no water, you cannot determine whether the material is acid or alkali. Okay, so what happened? You put water, you dilute it with water, then you take the litmus paper, whether the litmus paper is blue or red, and then you test whether it got changes or no. Okay, and then what happened when I put water over here? For example, I put water, right? I put water into the beaker here, into the evaporant dish. I put the water. This is water. I put the water inside, and then I just mix it around, so it will become soap. Not dry soap. It will become soap solution, right? It will become soap solution. Then you take a red litmus paper here. What will happen? Do you think?
Become blue.
Become blue. Yes, the red litmus paper become blue. So when the red litmus paper become blue, it is acid or alkali?
Alkaline.
Alkaline. You just remember, yeah. If the paper become blue, it is alkaline. If the paper become red, it is acid. This is for litmus paper, right? Okay, right. So 260. Okay, so for A, no changes. For B, the litmus paper do not changes because the powder is dry. Okay, you cannot test the dry material. You must put water. Yeah. Okay. Number one, the conclusion. Right. Acid can be defined operationally as chemical substance changes the color of damp blue litmus paper to red and has pH value less than 7. Okay. How about alkali? Alkali change the color of red litmus paper to blue and then the pH value is more than 7. Is it okay?
Okay.
Okay, good. Next page. 60. 68. I think I will skip this because maybe we want to try when we all go back to the school, we want to test the real things. To show you the real indicator, which one is pH and which one is alkali. No need to do this. We will try to do this in the school, right? And then page 69. Okay, 69. Sorry, 69 also. I think we try to do it in the school, at the school. So I will skip this. But discussion number one, this I think everybody is understand about this, right? The scale of pH, right? Ini semua faham ya?
Yes.
Observation, pemerhatian, page 69. We just skip it. You just do the discussion over here. Discussion number one. Less than 6 is acidic. Number 7 is neutral, and then more than 7 is alkaline. Okay. Okay, and then the conclusion: strong acid, smaller pH value. Strong alkali, greater pH value. Okay, can? Boleh ya?
Boleh.
Okay. Okay, again, in this topic, 6.1, please remember and then understand the properties of acid and alkali. Number one. Yeah. Number two, you must remember that the acid or alkali properties only show when there is water. When there is water, we can see whether the substance, where the chemical substance, whether it is acidic or alkaline. Okay, that's number two. Number three, the example of substance lah. For example, acidic, vinegar, lemon juice, alkaline, soap, and toothpaste, usually alkaline. And then the indicator. This is the indicator. Okay. What I show you early, this one, I just show you only one indicator, right? What is the name of this indicator? What is the name of indicator here? We call it
pH paper.
pH paper. Very good. pH paper. This is only one indicator. Actually, there are many types of other indicators. If you can see here, for example, number one, the indicator number one, we call it phenolphthalein. Phenolphthalein. Okay. The second indicator is what we call a universal indicator. Methyl orange. Blue litmus paper, we already know, right? Blue litmus paper, when there is acid, become red, and then neutral become blue, alkali also blue. Okay, this is blue litmus paper, right? The other indicator is phenolphthalein. Okay, what happened to the phenolphthalein when put into the when the phenolphthalein change to pink color? It is alkali. Acid colorless, neutral colorless. I will show you the example of phenolphthalein. Yeah, phenol. This is phenolphthalein indicator. This is phenolphthalein indicator, right? Make it a bit. This is phenolphthalein. Phenolphthalein is in what we call in solution, in liquid. When you put acid, no color. When you put alkali, it will turn to pink, or maybe about what we call a indigo color a bit. This is one of the indicator. Okay, this is what we call the one of the indicator. Okay, until what time? Yeah, our science class is until 12. Okay, 12 in the afternoon. Okay. Sorry. Okay, this is phenolphthalein. Okay, how about universal indicator? Universal indicator. This is universal indicator. Okay, universal indicator also in the solution. Okay, universal indicator also in the solution. Okay, the function is just like pH paper. Only the difference is pH paper use paper, right? They use a piece of paper, but in universal indicator use a solution. And then when you drop a few drop of when you put a few drop of universal indicator into a solution, it will change the color. It will change the color. Then you must match the color that changes to its scale here. Just like pH paper. Just like pH paper. This one pH paper, right? pH paper, you use paper. But universal indicator, you use liquid. You drop a few indicator and then it will change color. Red, usually acid. And then when it turns purple, usually alkali. Okay, maybe when we have the time, I will show you the universal indicator in the lab, in the school lab, after we all go back to school, right? Okay. Methyl orange. Methyl orange is like this. This is methyl orange indicator. This is methyl orange. When there is when methyl orange put in the alkali solution, it will become a yellowish. It will put inside a solution that is acidic, it will become reddish. Okay, this is methyl orange indicator. Okay, this is universal indicator. This is phenolphthalein indicator. And then this is pH paper. And then last one is litmus paper. Okay, only one purpose, whether we want to determine acid and alkali. There are many types of indicator. Yeah, there are many types of indicator. Okay, we want to find out what is the, whether it is acid or alkali, or we want to find out their value, whether it is pH 1 or pH 10 or pH 11. We also can determine by using various indicator. Okay, is it okay? You understand me, class? Okay, I hope you can follow me and understand lah. Okay, next one. Actually, there are much easier way to determine the pH value. pH indicator, pH, this one. This one is very easy. Okay. Ada jual there are this one what we call by a digital pH indicator. Okay. I think this one in Shopee. How many? 21 ringgit only. Oh, very good. Right. There is a device, electronic device that can accurately determine whether it is acid or alkali. Okay, there is a device. This is digital one using an electronic. This is much accurate. Okay, where is it? Oh, what is this? Okay, for example, we call it a digital pH meter. A digital pH meter. Only for 21 ringgit. You no need to use the what? You no need to use the indicator lah, a phenolphthalein lah, pH paper. There is an easier and quicker way by just using a pH meter. For example, you just dip it. You just dip the end of the device into the water, and then it will try to read the pH value. For example, like this. What is the pH value over here? 6.68, right? So you know whether it is acid or alkali. 6.68. Class.
Acid.
It's a little bit acidic, right? 6.68. It is because actually 7 is neutral. Okay. Actually, our skin is not neutral. Yeah. Our skin, our scalp over here is actually a little bit acidic. Okay. Our body surface cannot be neutral. A little bit of acidic. Now this is normal, but not too strong lah. The acid is not too strong. Maybe about, if I try to search body pH level. Body pH. Body pH is about, can you see this? The pH of the body is lies in a tight range between 7.35 to 7.45, meaning that neutral, right? It is not a little bit of acidic. It's about 7.35 to 7.45. This is for human, for pH of the human body. Okay. In the human body, the blood cannot be too acidic and cannot be too alkaline. Our blood. Okay, how about blood pH? Okay, our human blood usually is about 7.35 to 7.45. This is normal one. Cannot be too acidic, cannot be too alkaline. Okay, this is our human blood. If skin, human skin pH value. This is human skin. Around what? Can you see it? Can you see this? Human skin is about 5.5. 5.5 is what? Acid or alkaline?
Acid.
Acidic. Yeah. Our skin is a little bit acidic. 5.5. Okay. Inside our body, the blood is about 7. You cannot be too acidic, cannot be too alkaline. But if too acidic or too alkaline, our health will be affected. Okay. Skin is 5.5. Okay. Our scalp inside the head, inside the scalp here, in the surface skin of our head is also a little bit acidic. Okay, around 5.5. Okay, it is not neutral, right? Just a little bit of acidic because we want to protect the body, maybe from the bacteria or from the viruses. Must a little bit acidic. Okay. So, one more thing. Just want to share you lah. Coca-Cola. What's the pH of the Coca-Cola, you think? Let's see. How much? 2.3. Oh, strong or what is it?
Strong.
Acidic or alkaline? Is it alkaline? Sorry, is it acidic? 2.3. 2.3 is about strong acid actually. Coca-Cola. It is a strong acid actually. That's why some of the video you see on the internet, they use the Coca-Cola to clean the metal. You know? Can you see the video? They use Coca-Cola to clean the metal, to clean the toilet. I don't know what happened. Because why? You know, because the pH of the Coca-Cola is 2. 2 is a pretty strong acid actually. They try just use the Coca-Cola to clean the metal. Okay. I don't know whether you can test it on your own lah. But some of the video or the picture I search, yes, Coca-Cola can what we call remove the rust on the metal because of the reaction. You still remember the reaction metal and acid? What happened? Right. Maybe lah. Right. Okay. But it is not too strong that it can damage us. No. Okay. But it's quite a strong acid actually, the Coca-Cola. Okay. Right. Any question?
No.
No question, right? So the uses of acid and alkali, I think you can read for yourself. This one I asked you already, right? Formative practice.
Yes.
Okay, no problem. Okay, so I think I will stop here. When is our next class? Next class is tomorrow. Yes, sorry. Next class on tomorrow. Tomorrow I will see you again in at 9 in the morning. 9 in the morning, right? 9 o'clock in the morning. So we see you all again tomorrow, online classes. And then maybe you can, before our meeting, you can read 6.2 neutralization first in order to give you more understanding about the topic, right? You can read 6.2 first, okay? Before we meet again for tomorrow class at 9 a.m. Is it okay?
Okay.
Okay, very good. So I think I will stop here. Thank you for your cooperation. Thank you for your listening. So we all meet you again tomorrow. Okay, bye-bye. You can leave the class now. Thank you very much.
Thank you, teacher.
Thank you, bye-bye.
Teacher.
Thank you, bye-bye.
Thank you, teacher.
Thank you. Okay, bye.